We're actually going to Mars, and it's happening a lot sooner than you probably think. But once we get there, we face this single greatest biological challenge. How are we supposed to breathe? So today, we're going to dig into the incredible solution that's being tested right now, a machine that's literally making air out of the thin, poisonous atmosphere of a whole other world. Okay, just picture it. You step out onto the surface of Mars. You see this dusty, pink sky, a landscape that's totally alien and vast, but that first breath you try to take, it'd be your last. So how do you possibly survive on a planet where the very air is poison? That is the question we have to answer before we can even dream of calling Mars our second home. All right, so here's the game plan. First, we'll talk about why we're so obsessed with Mars, what we're calling the Martian imperative. Then we'll dive right into the great oxygen problem. After that, we'll look at some lessons from orbit to see how we handle this stuff today, and then we'll meet the star of the show, a Martian lung called MOXIE. And finally, we'll look ahead to the next great challenge. So first up, the Martian imperative. Why Mars, right? What is this gravitational pull the red planet has on us, on our imagination, and our biggest scientific goals? Well, it really boils down to two big things. On the one hand, you've got that pure human spirit of exploration, that need to just see what's over the next hill, or in this case, the next planet over. But there's also a much deeper, sort of existential reason: survival. A catastrophe like the asteroid that wiped out the dinosaurs, it could happen again. And Mars, well, it represents a backup drive for humanity, a way to not keep all our eggs in one cosmic basket.
And look, don't for a second think this is some far-off science fiction fantasy. This is happening right now. SpaceX is aiming for 2029 to land the first humans on Mars. NASA's targeting sometime in the 2030s. We are right in the middle of a new space race, and the finish line is kicking up the red dust of Mars.
Okay, so let's get to the real heart of the problem here. The great oxygen problem. Mars might look all majestic and beautiful from a distance, but up close, it's a deadly, deadly world for one very, very big reason. It's funny, if you just glance at the stats, Mars seems surprisingly like Earth. The day is almost the same length, it has seasons, it's even got polar ice caps. But the one killer difference is the atmosphere. Earth's is thick and full of life-giving oxygen. The Martian atmosphere? It's incredibly thin and totally, completely unbreathable. And this is the kicker. Right here, the Martian air is a whopping 95% carbon dioxide. For us, that's not just something we can't breathe. It's literal poison. The one thing Mars has tons of is the one thing that can't go in our lungs. So how in the world do we fix this? Well, the good news is we've actually got some experience creating our own air in a place where there isn't any. We just need to look up, about 400 kilometers over our heads, and check out the lessons we've learned from orbit. So up on the International Space Station, they have this really brilliant closed-loop system. It collects every drop of wastewater. We're talking astronaut pee, sweat, even the humidity in the air, and then it zaps it with electricity. That process, called electrolysis, splits the water into hydrogen and oxygen. The oxygen gets pumped into the cabin for breathing, and then, get this, the hydrogen is cleverly recycled to make even more water. It's just an amazing piece of engineering. You gotta love this quote from astronaut Douglas Wheelock. He said, "Tomorrow's coffee is made from yesterday's coffee." It just perfectly sums up how incredibly efficient this thing is. The system recycles about 98% of all the water on the station. Talk about the ultimate recycling program. But, and this is a big but, here's the catch. Even at 98% efficiency, the thing is, it's not perfect. The system is what they call leaky. There are always these tiny little losses and inefficiencies, and what that means is that it completely depends on constant resupply missions from Earth to top everything off. And you won't believe how expensive those resupply missions are. It costs over $20,000 to send a single liter of water just 400 kilometers up to the ISS. Just think about that. 20 grand for one bottle of water. And that's where it all really hits home. The ISS is basically in our backyard, just 400 kilometers away. Mars, well, at its closest, Mars is 225 million kilometers away. So resupplying a colony on Mars from Earth isn't just wildly expensive, it's just not gonna happen. It's basically impossible. We need a totally new plan. And that brings us to the hero of our story, a totally brilliant piece of tech that's basically a mechanical tree, a lung for Mars.
It's called MOXIE, and its whole job is to make breathable air from nothing but the thin Martian atmosphere. Now, MOXIE is built on this really simple but revolutionary idea called ISRU. That stands for in-situ resource utilization. It's really just a fancy way of saying live off the land. Instead of packing everything you could ever possibly need, you just figure out how to collect, process, and use the stuff you find when you get.
So how does this Martian lung actually work? Well, it's a pretty cool three-step process. First, it inhales. It sucks in that nasty CO2-heavy Martian air. Second, it squeezes that gas down and heats it up to a blistering 800 degrees Celsius inside a special gold-plated device. And finally, it exhales, cracking that CO2 molecule into two things: pure, breathable oxygen and a waste gas, carbon monoxide.
And guess what? It totally works. MOXIE has successfully made oxygen on the surface of Mars. Okay, now let's be real, the amounts we're talking about are pretty small so far, about 122 grams in total. That's only enough to keep a single astronaut breathing for maybe 3.5 hours. But even though the amount is tiny, this is a huge, monumental proof of concept. It proves the science is solid. So there we have it. We've actually made oxygen on another planet. Which brings us to our last section, the next great challenge. How do we go from a little experiment the size of a toaster to a system that can support an entire world? So there are basically three big hurdles we have to get over. First is just scale. We're going to need a version of MOXIE that is hundreds of times bigger to make enough oxygen for a whole colony, not to mention for rocket fuel to get home. Second, power. You don't get something up to 800 degrees for free, so this giant system will need its own massive power plant on Mars, probably a nuclear one. And finally, innovation. Scientists are already looking past MOXIE, trying to find even better ways to crack CO2, maybe using vibrations instead of all that heat, which could be way more efficient on Mars. And all of this, it leaves us with one final huge question. What MOXIE proved is that the science isn't the biggest obstacle anymore. We know we can do it. We can create a little bubble of breathable air on a hostile planet. The technology is right there, within our grasp. So the real question isn't about tech anymore, is it? It's about us. We've proven we can make the oxygen. The only question left is, do we have the will to actually go and build a world with it?